The requirements for 50 amp and 40 amp circuits for top-end ranges and cooktops are based on the potential maximum load that these appliances can draw. While it is true that the full load may not be used in all cases, it is important to consider the worst-case scenario to ensure that the electrical system is properly protected. The National Electrical Code, or NEC, requires that electrical circuits be installed to carry the maximum possible load that the appliances or equipment connected to the circuit may draw. This is to prevent overloads and potential electrical hazards. The NEC does allow for some exceptions to this rule, such as allowing 30 amp circuits for ranges and cooktops that have a maximum load of 24 amps. However, this exception does not apply to top-end ranges and cooktops that require 50 amp and 40 amp circuits. If the manufacturer's installation instructions call for a 50 amp circuit for a range or a 40 amp circuit for cooktop, it is important to follow those instructions. The manufacturer has designed the appliance to operate safely on a circuit of that amperage rating, and using a lower amperage circuit could lead to overloading and potential safety hazards. The ODG, or authority having jurisdiction, has the final say on whether or not to require the use of 50 amp and 40 amp circuits for top-end ranges and cooktops. If the AHJ does not require the use of these larger circuits, it is important to document the decision and obtain a variance or other form of approval from the AHJ. This will help to protect the electrician from liability in the event of an electrical problem. Regarding the use of different manufacturers' breakers in panels, 110.3 B of the NEC requires that all circuit breakers in a panel be of the same make and type. This is to ensure that the breakers will trip properly and provide the necessary protection for the electrical system. If different manufacturers' breakers are found in a panel, it is important to replace them with breakers of the same make and type. To elaborate on the topic of range and cooktop circuit sizing according to the National Electrical Code, we need to consider several factors to ensure a safe and compliant electrical installation. Firstly, the NEC mandates that circuits be sized to handle the maximum potential load of the connected appliances. This means taking into account the nameplate rating of the range or cooktop, which indicates the maximum power it can draw under full operation. Ignoring this can lead to overloaded circuits, posing a fire hazard. Secondly, while the NEC permits some exceptions for smaller ranges and cooktops, allowing for reduced amperage circuits, these exceptions typically do not apply to high-end models with higher power demands. These high-end appliances often require dedicated 50 amp or 40 amp circuits as specified by the manufacturer. Thirdly, the manufacturer's instructions play a crucial role in determining the appropriate circuit size. These instructions are based on the appliance's design and testing, ensuring safe operation. Deviating from these instructions can void warranties and, more importantly, compromise safety. Fourthly, the authority having jurisdiction, or ODG, holds the ultimate authority in interpreting and enforcing the NEC. While the AHJ may sometimes grant variances based on specific circumstances, it is essential to document any such decisions and obtain written approval to avoid future liability. Fifthly, the issue of using different manufacturers' breakers in the same panel is addressed in NEC section 110.3. B. This section requires that all circuit breakers within a panel be of the same type and make. This is to ensure consistent and reliable operation, as breakers from different manufacturers may have varying tripping characteristics, potentially leading to inadequate protection. Now let's delve deeper into each of these aspects. Firstly, the NEC requirement for sizing circuits based on maximum load is a fundamental principle of electrical safety. Overloading a circuit can cause the conductors to overheat, damaging insulation and potentially leading to a fire. Therefore, it is imperative to calculate the total load connected to a circuit and ensure that the circuit conductors and overcurrent protection devices are adequately sized to handle that load. Secondly, the exceptions allowed by the NEC for smaller ranges and cooktops are typically based on the assumption that these appliances will not be used at their maximum capacity simultaneously. However, this assumption may not hold true for high-end models, which often feature multiple high-wattage elements and advanced features that can draw significant power. In such cases, it is essential to adhere to the manufacturer's instructions and provide the specified circuit size. Thirdly, manufacturers' instructions are not merely suggestions, they are based on rigorous testing and engineering analysis. These instructions specify the minimum circuit size required for safe operation, taking into account factors such as conductor ampacity, overcurrent protection, and appliance ventilation. Ignoring these instructions can lead to overheating, electrical arcing, and other safety hazards. Fourthly, the AHJ role in enforcing the NEC is critical to ensuring consistent and safe electrical installations. While the AHJ may sometimes grant variances based on specific circumstances, such as the availability of existing wiring or the specific characteristics of the installation, it is important to document these decisions and obtain written approval to avoid any potential legal issues. Fifthly, the requirement for using circuit breakers of the same make and type in a panel is based on the principle of standardization. Circuit breakers from different manufacturers may have different tripping curves, meaning they may respond differently to overloads and short circuits. This can create a situation where one breaker trips prematurely, while another fails to trip at all, potentially leading to damage to equipment or even a fire. Therefore, it is essential to use circuit breakers of the same make and type to ensure consistent and reliable operation. Moreover, when installing or replacing a range or cooktop, it is crucial to consider the following additional factors. 1. The distance between the appliance and the electrical panel. Longer distances require larger conductors to minimize voltage drop, which can affect appliance performance and efficiency. 2. The type of wiring used. The NEC specifies different ampacity ratings for different types of conductors, such as copper and aluminum. It is important to select the appropriate conductor type and size based on the specific application and local code requirements. 3. The presence of other loads on the same circuit. If the range or cooktop shares a circuit with other appliances or equipment, it is essential to calculate the total load and ensure that the circuit is adequately sized to handle it. 4. The proper grounding of the appliance. Grounding is essential for safety, as it provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. 5. The proper installation of overcurrent protection devices. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. It is important to select the appropriate overcurrent protection device based on the circuit ampacity and the type of equipment being protected. 6. The proper labeling of circuits and panels. Clear and accurate labeling is essential for identifying circuits and their corresponding overcurrent protection devices. This helps to prevent accidental disconnections or overloads and makes it easier to troubleshoot electrical problems. 7. Compliance with all applicable codes and standards. Electrical installations must comply with all applicable codes and standards, including the NEC, local building codes, and manufacturer's instructions. Failure to comply with these requirements can result in fines, delays, and potential safety hazards. Now consider the specific scenario where the manufacturer's instructions call for a 50 amp circuit for a range, but the electrician is tempted to install a 40 amp circuit instead, based on the argument that the full load will never be used. This is a dangerous practice that should be avoided. The manufacturer's instructions are based on the appliance's maximum potential load, and using a smaller circuit could lead to overloading and overheating, even if the appliance is not always used at its maximum capacity. Moreover, even if the AHJ allows for a variance in this situation, it is important to document the decision and obtain written approval to protect the electrician from liability. In the event of an electrical problem, the electrician could be held responsible if they deviate from the manufacturer's instructions without proper authorization. Furthermore, when replacing circuit breakers in a panel, it is essential to use breakers of the same make and type. Mixing breakers from different manufacturers can lead to inconsistent tripping characteristics and potential safety hazards. If breakers of the same make and type are not available, it is recommended to replace the entire panel with a new one that uses compatible breakers. In conclusion, sizing circuits for ranges and cooktops requires careful consideration of the NEC requirements, manufacturer's instructions, and the AHJ decisions. It is essential to prioritize safety and compliance, and to avoid cutting corners or deviating from established standards. By following these guidelines, electricians can ensure safe and reliable electrical installations that protect both property and lives. The additional considerations for range and cooktop installations include ensuring proper ventilation to prevent overheating, using appropriate wiring methods for the environment, and providing adequate clearance around the appliance for safe operation and maintenance. It's also crucial to conduct thorough testing and inspection after installation to verify proper operation and identify any potential issues. Remember that electrical codes and standards are constantly evolving, so staying updated on the latest requirements is essential for all electrical professionals. Continued education and training can help electricians stay informed and ensure they are providing the safest and most compliant installations possible. Furthermore, when dealing with high-end appliances that require specific circuit configurations, consulting with a qualified electrical engineer can provide valuable insights and ensure that the electrical system is designed to meet the appliance's unique requirements. Electrical engineers can perform load calculations, analyze voltage drop, and recommend appropriate wiring and overcurrent protection devices to ensure optimal performance and safety. In addition to the technical aspects of range and cooktop installations, it's also important to consider the customer's needs and preferences. Discussing the appliance's intended use, cooking habits, and budget can help determine the most appropriate electrical solution. Providing clear and concise explanations of the NEC requirements, manufacturer's instructions, and the potential risks of non-compliance can help customers make informed decisions and appreciate the importance of safety. Ultimately, the goal of any electrical installation is to provide a safe, reliable, and compliant system that meets the customer's needs while adhering to the highest standards of quality and safety. By following the guidelines outlined above, electricians can ensure that range and cooktop installations are performed correctly and safely, protecting both property and lives. Always remember to prioritize safety, follow the NEC and local codes, and consult with qualified professionals when needed.